All right, so it's going to be hard to follow up on that amazing talk by Professor Guyton. But so I'm here to talk about two ideas. In fact, this is a 2-for-1 deal. It's about one idea that I've worked on, which has led to a new idea. So the first thing I want to talk about is Checkered. Checkered is a semester scheduling website that I started about 2 years ago, and it's been a really great experience. The way Checkered works is that, say you're a sophomore in the College of Engineering and you have a class at noon on Friday. You have a lab, say, and you don't want to have labs on Friday because it's a Friday and you want to get your weekend started early. So what you can do on this website is you can drag it, and here you can see that once you do that, you can see all the different times this class is offered. And if you prefer to have it on Thursday at 2:30, you can just drop it, and there it goes. So it's a really simple, nice concept. And I thought it was a really great idea because at that time, our predecessor would give you every single combination of schedules that you could possibly build with these classes. Because classes are offered at different times during the day. Physics class might be offered at 10 and 11 o'clock. The labs are offered at a lot of different times, as you can see here. So with a schedule like this, our predecessor would give you 33,374 different schedules to look at. And if you're a freshman and you have a lot of different things to do, you don't really want to look through 33,000 different schedules. So my analogy is you go to Starbucks, and if Scheduleizer designed your menu for you, it would look something like this. And it would go on for about 200 pages. And after a while, you just give up and go to CPP or something. So it's not about how many ways you can order coffee. It's about getting it exactly the way you want. And that's where Checkered is. So I thought I'd talk about that real quick because it segues into the next idea, which came out of working on Checkered. To build Checkered, we needed two types of data. We needed the list of classes that were being taught in a semester, and we also wanted to provide descriptions of each class. So the first was simple. The first was the list of course data, and this came out really nicely. The computer understands this perfectly. And this is in part because of Scheduleizer. And so I'm not entirely, I'm not just beating down on them. They've done a lot of great work building. They did a great job in providing the foundations for our site. This is provided by the registrar. It's a computer-readable format. It's really wonderful. And so this was the first piece of data that we needed. However, the second piece was the course descriptions. And this looks like this on Cornell's website. It looks really nice. We understand it. That there are history classes and they're taught at so-and-so times, and these are the descriptions. These are offered this year and so on. However, the computer sees this. This is gibberish to the computer. The computer has no idea what the class is. They don't know when the class is being taught, what the class number is, and so on. And so this is a problem with the internet at large. Data is trapped in private silos. For instance, if I wanted to create an iPhone app which could tell you the hours that Cornell libraries are open, I would have to go to Cornell's website to get that information. If I wanted to create an iPhone app which told you where the nearest bus stop was, I would have to go to the CCAN website. And so all this information is stored in little databases that are behind different websites, and they have different interfaces to them. So it's hard to get the information you want. And so my thinking was, wouldn't it be wonderful if there were a single repository where you could go for all this information, where it was predictable, it was structured, it was, it would take you 5 minutes to be able to figure out how to put that data into your application. This would free up this information in no sense. And so my solution was Checkered, Granary. Yes, I confuse them a lot. So this is the democracy of data. This is the prototype, and you can see that there are different, I've already put in a few things like library hours, bus stops, and so on. And the wonderful thing is that you don't need a website to look at this information. You can go onto our website and you can click on library hours and you see all this information laid out nicely for you. And if you're Cornell and you put your data in our database, you can take that information and display it on your website as well using the API we provide, the interface that we provide for this. And if the creator of the database so chooses, they can open it up to the public to edit as well. So this adds a Wikipedia aspect to the data, where incorrect data can be updated, can be fixed, can be improved upon. So for instance, if I've created a database of bus stops and I've forgotten the one by RPCC, someone could add that for me. And anyone who's using that data would have it updated at the same time. So everything's consistent, everyone sees a single view of the information, and it's this utopia in a way. So the features are that there are public and personal lists. That's the first important thing. I didn't want to make something that was so technical that only an IT department could use it. So in fact, Granary is really simple to use. And if you wanted to create a grocery list to share with your family, you can do that. There's a simple web interface for you to create a list. It's sort of like a stripped down spreadsheet in a way. You have columns, you have rows, and it's predictable. And you can share that with people. You can share a list of favorite restaurants to eat in Ithaca with a bunch of people, and people can add to it. There are different types of columns. There are columns where you can rate each element in the list, and so on. And so that brings us to the second point, collaborative editing, which I've spoken about. It allows everyone, it harnesses the power of the community, it harnesses the fact that we know more than I know, that together we know a lot more than any given individual. It's how Wikipedia works. It's why Wikipedia has become the world's greatest dictionary, for instance. And the last aspect is the structured and searchable nature of it. And this is perhaps to me the most interesting thing. This solves the problem of where the computer sees gibberish. If you use this database and you put your data in a predictable format, the computer will understand it and will be able to read it. So I'll leave you with I'll talk about. My last point is what Google is doing. Google is trying to do this in the opposite direction. This is one of their beta projects called Square. What it does is you type in planets, for instance, and it'll create a spreadsheet of planets based on information that is found on the internet from Wikipedia and so on. It'll give you like Jupiter, Earth, and then it'll give you a description, pictures, the diameter, and so on. And it's nice. This looks really complete, except you get the moon there, which isn't really a planet, and I think Pluto was demoted at some point. But if you scroll down, it gets interesting. You start to see things like the sun and Naboo, Hawk. And these are not planets I've heard of in real life. I think these are from Star Wars. And so you get this problem of noise. There's a lot of noise in public data. And when Google tries to do this, they search the entire internet for information. And it's not always accurate. And so my approach is different. My approach tackles this problem from the other direction. So if somebody created a database of planets, you just go to our website and you just type in planets and you get this. Simple, to the point, and all the information you need. And if one day you decided to add Pluto back in, it would just appear at the bottom. And you wouldn't need to do a thing. It would just appear in your data, in your program that you're using this information for. And I think that's the last slide. Okay. Oh, wait, there's one more. So that would look like this, and it's really structured. The planets, this thing is backed by this, and it's really, it's in that predictable, computer-friendly format that I talked about. So this is my dream for data, to make things accessible to everyone, to create a democracy of data where we don't have to struggle to find creative ways of gathering data from public websites in order to create useful apps for people. Thank you.